Welcome back again, solving another good numerical problem for NEET 2021 and also for JEE Main for 2022. If you look at the pulley system here, I suggest you go through my previous videos on pulley systems. Look, this is a fixed end. Here is a string going around this pulley, again around this pulley, and from this pulley a mass is hanging, and the string again passes over another fixed pulley here and is connected to a mass here. So these two pulleys are fixed. This is a movable pulley. So the acceleration of this mass and this mass will not be same, as I have discussed in previous problems. Now you can take this as M1, you can take this as M2, or you can take this as M1 and this as M2. But for simplicity, I will take it as 1 kg, and I will take this as 3 kilograms. You can take this as 3 kg, this as 1 kilogram, no problem. But the explanation remains the same. So let me go to another diagram which I have redrawn for you. The same situation. What is to be understood here is, as this pulley, which is a movable pulley, falls down to a new position here, this is the central line of the pulley before it fell down. This is the central line of the pulley in the new position. Suppose this distance from here to here is equal to x. So when the new position of the pulley is here, what part of this string? Look, the length of the string is fixed from here to here to here and to here. The length is fixed. Since this end is fixed, what will happen when this pulley falls down by a distance x? The length of the string will be shortened from this side. If this distance is x, the string will go around like this in the new position. So from here to here is x, from here to here is x. So 2x length of the string will be reduced, will be shortened from this side. Means this mass will move towards right by a distance 2x when this pulley falls vertically down by a distance x. That is the understanding. And everything happens simultaneously. So if the acceleration of this pulley along with this mass downward is a, of this mass to this side, the acceleration will be 2 times that. X 2x. So a 2a. Now then it is simple. If you take this as M1 and this as M2, then the equations will look like this. It is the same string. This is tension T. For this, it will be to this side, away from it. The same tension T. The same for here, the fixed support. Now, if you look at here in this string, what will be the tension? This string is pulled up through this pulley, T on this side and T on this side. So here the tension will be 2 times T. Now, so since this is falling down with acceleration A, its weight is vertically downward M1 times G. Now, so for the M1, the equation would look like M1G minus 2T. I'm writing here. M1G minus 2T will be its mass times its acceleration, that is A. Now, and here it is the tension T that is pulling this mass M2 towards right. So for this, T will be its mass M2 times its acceleration, which I just explained. It will be 2 times A. Now there are two equations. Now if you add it here, this t won't cancel, so you have to multiply this equation with 2, then add to equation 1. If I multiply with 2, this becomes 2t, 2 multiplied here 4 times m2a. Then just below it I write this equation, that is equal to m1g minus 2t is equal to m1 times a. So there are, now if you add the left hand side of this with the left hand side of this, tt, 2t, 2t cancels. So I am left with m1g is equal to, on the right hand side if you take a common, is we are left with m1 plus 4 m2. So your acceleration comes out to be, this is multiplied, comes to the right hand side, is m1 over m1 plus 4 m2 times g. So this is your acceleration. So acceleration of the pulley along with this mass m1 will be a, and the acceleration of this towards right will be 2 times this, means 2 m1 over m1 plus 4 m2 times g. Now to find tension, we have to put the value of this acceleration either in equation 1 or in equation 2. But in equation 2 it will be easier to find, so let me put it in equation 2 here. So your t is equal to m2 times 2a, m2 times 2 times a, that is to be, so m2 I write m2, 2 times this acceleration, that is 2 m1 over m1 plus 4 m2 times g, 2 times this acceleration. So this becomes 2 m1 m2, 2 m1 m2 over m1 plus 4 m2 times g is your tension. So the tension in the string, it is the same string, remains all throughout same, and and if the acceleration of this pulley along with this mass m1 is to this side is a, then the acceleration of m2 to this side will be 2 times that, because if this pulley falls by a distance x, what length of the string on attached to m2 will be shortened? X on this side and x on this side, x, 2x. So from this side 2x length will be available to this mass and to this pulley and this mass on this side, because this end is fixed. So the length of the string will be shortened from this side, and that will be available on this side, and it will be equally distributed to the left and to the right of this pulley. So if this is x, this is x2x. When this falls by a distance x, the length of the string that is shortened from this side, not from this side because this is fixed, will be 2 times x. So if this acceleration is a, this will be 2 times a. So that is all about. I will upload few more videos before your NEET 2021 to be held in September of 12th next month. So please go through it, and if you like, you can give a thumbs up and subscribe also. Thank you.